let me turn on my screen, share my screen. Let me go to the website. Open Math. There it is, my Open Math right there. There. And let's see how many people are coming in here. Okay. We're in chapter 6. Let's give it another minute or so for people to come in. And it looks like the weather is keeping people away. People don't like statistics when it gets warm. All right, that's all right. That's okay. We'll see if they'll watch the video. Okay. All right, guys. Why don't we just start and get it over with? What I'd like to do for sure is in going over this, we're going to pretty much stay in chapter 6. What we're going to do is take a look at 6.1, 6.2, those two homeworks, and then I'm going to do a little bit of 6.3. So officially, we're not going to really finish chapter 6 until next week because chapter 6.3 or that homework tends to be a little longer than most. But I'll do a little bit of that homework so that maybe you get it, and you can go and you don't need me, and you can try to go ahead and do chapter 6 and finish chapter 6. So, all right, let's take a look at some slides like always. And how come I'm not getting any slides here? Oh, there it is. Okay, there's some slides. Okay, first things first. Uniform distribution. Now let's go back. I just want to go back to the website one more time because I wanted to show you. See, we did some probability distributions last time, but those are called discrete probability distributions. And what does that mean? Well, let's just take a homework. Take one of those homeworks. And okay, here's a discrete probability distribution. In your experiment, you can apparently 0.05%, 0.05, 5% of the time, you'll get nothing coming out of your experiments. 30% of the time, you'll get one thing coming out of your experiments. See, the values that you get out are discrete. They're perfect. You can't get any better than counting 1, 2, and 3. Okay, so those values are exact. And exact values like integers are called discrete values. Now, we're getting out of that world now. When we talk about chapter 6, we're talking about probability distributions that are continuous. Continuous is different from discrete. Let me show you what a continuous is right here. Come on. Oh, I have it already. Okay. Here's a continuous distribution. Okay, apparently what this guy is doing, or what this person's doing, is measuring waiting times for certain train station. Okay, and so what this distribution is indicating is that it's a uniform distribution. Look at the graph; it's a constant. Okay, so if I asked you what is the probability that the person has to wait 4 minutes, okay, here's the problem. Here's the issue. When you want to say, when you're dealing with a continuous distribution, the probability that a person has to wait 4 minutes is 0. That's the important thing to get. 0, because, all right, or even better than waiting, a person's height. You measure a person's height, a person's 5'11", okay? It's mathematically impossible to say that a person is exactly 5'11". He could be 5'11.6763. He could be 5'11, 5.10.99. Okay, it's impossible to get exact values or measure exact values in the world of continuous when you're having decimal points. What is possible is to say that within a range, the probability that you're within a range is that's something that you could do. Okay, the waiting times within the range from 4 to 5 apparently is 10%. See, the area under this curve is supposed to represent a probability distribution. In a probability distribution, the area under the curve has to be 1 because all probability distributions have to add up to 1. The area under this curve is 1. That's a given. So if I ask you what's the probability of waiting times between 4 and 5, you'd have to say it would be a tenth of the overall. A tenth of 1 is 1/10. And so with a uniform distribution, it doesn't, as long as you have equal ranges, it would be the same probability. See, the probability to go between 8 and 10 is the same probability as going between 4 and 6. So between 8 and 10 would be like 20% of the overall probability curve. So it would be 0.2. And that's really all you have to know about uniform distribution. Okay, so we can actually answer those questions for 6.1. Really, there's not much more. If I try to say more, it ends up being thinking that it's more complicated than it really is. Let's go ahead. I'm going to reset. I'm going to start. Well, there's only 4 questions too. Fantastic. Okay, fantastic. The graph of a uniform distribution is a straight line. You saw in that graph, in that slide, it was just a straight line. Okay, straight line. Where's straight line? Right there. Straight line. Okay, got that right. Perfect. Thank you. Perfect. Okay. Now, you have a uniform distribution between 6 and 11. Remember, the area under this rectangle is 1. Why is it 1? Because it represents the sum of all the possible probabilities within ranges. The sum of this range from 6 to 7, the sum is a probability. From 7 to 8 is a probability. We add up that. They all have to add up to 1. So what you have between 9 and 7 is basically what? 2 units out of a total of 1, 2, 3, 4, 5. So you don't really care what the true area of this rectangle is here. All you care about is the percentage, the probability. And probability is a percentage of the overall. You know that there's 1, 2, 3, 4, 5 units overall, and you want to find out what the probability that your value is within 2 of those units. 2 over 5. Just all you have to say, 2 over 5. 2 over 5 is 0.4. What's that? We're supposed to be 0.4, but is it percentage? 2 over 5. 2 over 5. Okay, I got a chat here. Okay, what homework are you on again? We're on 6.1. 6.1. We're doing chapter 6. Okay. All right. Oh, I didn't even turn my camera on. Not that you need to see me. But to see that this is not Chat GPT. I'm not doing artificial intelligence here. Let's see. Here, that's me. There you go. All right. So 2 out of 5. Let me see if I said 0.4. If I said 0.4, would it take that? Because 2 over 5 is 0.4. It took 0.42. All right, that's good. All right, so that's question. Now let's do question 3. The time it takes me to wash dishes is uniformly distributed. Between 6 minutes is the minimum, 16 minutes is the maximum. What's the difference between 16 and 6? I guess it would be 10 minutes. And everything is uniformly distributed amongst 10 minutes. What's the probability that washing dishes will take me from 9 to 14? Well, the overall is 10 minutes. And all we care about is the amount of time between 9 and 14. And if you take the difference between those two, that would be 5. 5 over the overall 10 would be 1/2, 50%, 0.5. Enter an integer or decimal number, 0.5. There you go, 0.5. Okay, and all right, great. What is the probability? This is what they're saying here. What's the probability that a value is between 5 and 6? Well, the overall is from 2 to 7. From 2 to 7 is 5 units, 7 minus 2. And all we care about is the range between 5 and 6, which is 1 unit. 1 over 5. 1 over 5 is 0.2. 0.2. 0.2, 0.2, 1 over 5, that's okay too. And I think it'll take the 0.2 as well. Okay, great. All right, that homework is done. Perfect. Nice. That homework is done. Let's now, things are going to get a little bit more complicated, especially when we started talking about normal distributions. And let's take a look at that normal distribution right over here with normal distribution. Let's show you a graph of the normal distribution. This looks complicated, but it really isn't. And it's really something that is common sense. Okay, what the normal, and why they call it normal is this. When you're taking measurements of something like a person's height, a person's age in a class, or you're measuring the number of I don't know, trees in a forest or in a certain year or something, okay, you find an average. There's an average number right there. Think of that. We have an average number, the person's height. Think of it in terms of person's height. There's an average. Okay, it makes sense that as you go away from the average, there would be more people close to the average. The probability that you're close to the average, plus or minus, okay, there will be more people as you get closer and closer to that average. You expect less people to be near that average. Okay, like there's the average height's like 5'10" or something like that for men. 5'10". Okay, you expect a lot more people to be 5'11" as opposed to 7.3. Okay, there's only going to be a few people that are 7.3. Right. So that's what a normal curve basically describes is that you have an average, and when you take a look at all your data points, that they tend to be around the average. And as you get away from the average, plus or minus, you expect less and less people or things to be found in nature, and they call that a normal distribution. All right. So what's important with the normal distribution is the average, for sure. And then the sigma, which is what we've been using so far, is the standard deviation. It's the standard deviation that we've been calculating with all these different formulas. Okay, and so let's go ahead and say, let's take a look at this empirical rule. Take a look at the empirical rule. And so if you say that things are normally distributed, which for the most part, everything that you measure in the world is going to be normally distributed. All right. There's no reason for them not to be. That if you can calculate the standard deviation, it turns out that you're going to be 68% of the data is going to be within plus or minus one standard deviation of the average. In other words, if we go back to this picture, here's one standard deviation right over here. 68% of the data is going to be within plus one standard deviation and one minus standard deviation. 68%. And that also means, remember, when you're dealing with normal curves and probability distributions, the area under the curve right here, the entire curve, the area is going to be 1. Because that's what the probability distributions are supposed to have, an area of 1. When you go plus and minus 1 standard deviation, I bet you the area within that curve from this range to this range is going to be 68%. And what are we saying? There's a 68% chance that a data point is within plus or minus 1 standard deviation of the average. That's what they're saying. And that's what they're saying over here. Now, do we have a better picture? Here's a better picture right there. Yeah, that's a better picture. Okay, 68% here, 2 standard deviations, plus 2, minus 2, it would be the distance from here to here. That would be 95%. 95% of the data would exist between 2 standard deviations plus and minus. So I bet you the area from here to here would be 95%. And the other areas, these little tails that you see here, would represent the 5% of the data that would be like the outliers. Okay. If this were a person's height, 5'10" being the average. Okay. The Shaquille O'Neals would be over here. Those are outliers. Those guys, you don't see that many 7 feet 1 inch people. Okay. And so that would be an outlier. So as you add more and more standard deviations, though, right here, here's more and more standard deviations. Now, just 3 standard deviations, plus or minus, you get 99.7% of the data locked in. Okay. And that's called the empirical rule. And okay, let's see if we can grab that. I think we can do homework based on this. And that's the 6.2, 6.2, 6.2 right over here. And you're going to see it's not that bad. Not that bad to do 6.2, 6.2, normally distributed empirical rule. Okay, let's reset, start over again. And okay. Unfortunately, this picture doesn't look too good. Okay, because you know these little, you don't even see these though. You know, so I guess it's all right. It's okay. You're gonna see these little boxes here. They should be farther apart. That's what my point is. But anyway, this is supposed to represent a normal distribution with 44 minutes as the mean. That would mean that this would be 44. That would be the value of that box there. 1 standard deviation in the plus direction means that this value would be 47. In the minus direction, mu minus sigma would be 41. So 2 standard deviations mean, okay, 44 is your center. 2 of these sigmas, 2 of these standard deviations would give you 6. 44 plus 6 is 50. And while I'm here, I might as well throw a 53 over here because every standard deviation is 3. Now let's see, 44 is the middle. Subtract two threes. Subtracting 2 3s would be what, 38? And this would be 35, 3 less than that. Let's check to see if that's right. Wow, that's good. That's 7 points. That is 7 points. Wow. Okay. For that problem there. Let me take a quick look and see. I guess I'll do 2, you'll do 3. Okay. Use the empirical rule, which means the rule is, let me jot this down. You don't need to see my face. You don't need to see my face. Let's me jot down the rule. Okay. 68, 95, 99.7. That's the empirical rule. Empirical. Okay. 1 standard deviation, 2, and 3. Right there. That's what you think about when you do this homework. Now, draw a sketch of the normal distribution and the label. Okay, we can do that. But assume that the weight of 1-year-old girls in the United States is normally distributed with a mean of 9.5 and a standard deviation of 1.1. 68% of the data lies within 2 values. Which 2 values? Okay, here's my little picture. Not very good, but you get the idea. Okay. The average is 9.5 kilograms. 68% has to exist within 1 standard deviation. 1 standard deviation is 1.1 here and 1.1 there. That's 68%. So what I got to do is add and subtract 1.1 from 95. So if I were to subtract 1.1, I get 8.4. And if I were to add 1.1, I would get 10.6. Okay, check it. That's great. Again, you don't see those little boxes. I just want to make sure I'm doing this right. I don't want to screw you up. Okay, so 95% of the data is within 2 values. Now, they're asking you questions specifically with 98, 95, and 99.7. They're not going to ask you 30% of the data. That's in the next section. Okay. These are the specific numbers, 1, 2, or 3 standard deviation in order to do these questions here. 95% means 2 standard deviations. 2 standard deviations of 1.1 is 2.2. I have to add and subtract 2.2 from the average. 2.2 would be 7.3. I subtracted 2.2 from here, and I add 2.2 to give me 11.7. Okay, check that. Yeah, feeling good. What percentage of the data is less than 6.4? Okay, here we start doing some thinking. We got to do some thinking. Here's our data. Here's our standard deviation. I'm going to try to make as good a curve as I could possibly make it. Okay. Here's one standard deviation here. 1 sigma. 1 sigma. We know that 68% is within this range. Okay. Outside the range is going to be 32%. 1 minus 68% is going to be 32%. Half of it will be over here. Half of it over here. So 1 minus 68% are sort of like the outliers. That gives me 32. Half will be in this tail. The other half will be in this tail. So divided by 2. I would say 16% of the data would be less than the 8.4. And why 8.4? Because 8.4 was 1 standard deviation away from the average, and they want to do things that are less than. Okay, this normal curve is perfectly symmetrical. That's why I can say just divide by 2. All right, if it wasn't symmetrical, you couldn't make those assumptions. What percentage of the data is between 7.3 and 11.7? That's the magic with what percentage of data? I guess it's 95%. Right there, 95%. There you go. It's basically telling you to duplicate this question. And what percentage of the data is more than 12.8? 12.8. I don't see 12.8 as my magic numbers, but 12.8. Let's see. 12.8 minus 9.5 is 3.3. 3.3 is 3 standard deviations, 3 sigmas. 3 times 1.1. 3 standard deviations. So they purposely picked 9.8 so that when you do this out, and this is not a good curve, okay, you have 3 standard deviations here, 3 standard deviations here. And we know within those standard deviations, 99.7% of the data is going to be within that range. The extreme outliers would be 1 minus 99.7%, which would be what? 1 would be 0.3%. 0.3%. Half of them will be extremely small. Half of them will be extremely big. So I divide by 2, and I get 0.15% as my answer for that guy. 0.15. Okay, 0.15%. Okay, 0.15% is the answer for that guy. So what do you think? What do you think? And that's all this thing. That's all this chapter is. Chapter 3 is just like this. Question 3 is just like that. Let's do number 4. For 4 units, for a 4-unit class like statistics, students should spend an average of 12 hours studying for the class. Okay. A survey was done on students, and a distribution of the total hours per week is bell-shaped, which means normal distribution, with a mean of 14 hours and a standard deviation of 3 hours. Yeah, this isn't a perfect world, of course. Sure. Okay. I got people in my class that haven't done any homework at all. So I guess those were the extreme, those would be the extreme outliers. Okay, within the 3 standard deviations. Anyway, let's jot down some rules. The average would be 14. So my mu is 14. That's my average. And my sigma standard deviation is 3 hours. Okay. 97%, 99.7% of the students have studied between which values? Okay. Okay, 68, 95, and 99.7 is 1, 2, 3 standard deviations. Okay. 99.7 means I got to deal with the 3 standard deviation number. And so, okay, we got enough. All I got to do is calculate 14 plus 3 standard deviations of 3. And then I got to do 14 minus 3 standard deviations of 3. So 14 plus 9, 14 minus 9 would be 23 maximum, and this would be 5 minimum. I'm going to go with those numbers. Some people go 5, some people do 23 hours. I don't think you need those big boxes, but 5 and 23 is what you have. Okay, what percentage of students study are below 20? Now, below 20, okay. They won't ask you questions that don't give you the magic numbers of 68, 95, and 99.7. Not yet. They'll do that in the next homework. But 20, okay, 20 minus 14, and actually the number of standard deviations, this is a nice little formula you should know. Okay, x minus mu, which is the average, x is your data point, divided by sigma, that's, and I should call that the z value. Z is the number of standard deviations. Okay, x minus mu divided by sigma is equal to z. X, they're worried about 20 minus the 14 divided by 3 is my z, and they call that the z-score. That's the thing that we're going to talk about in the next homework assignment. The z-score is basically the number of standard deviations away you are from the average. We have 6 divided by 3, which is 2. Okay, it comes out nice and even. 2 means that we're working with the 95% range. 95%. So what percentage of the students have study hours that are less than 20, below 20? Remember, don't just say 1 minus 9. See, the 95% is in between. That's the 95%. From here to here is 95%. The data would lie within the range. They want us to say, well, here's your 20. How many people are extremely not interested in statistics? And then there's going to be some people that really love statistics, so they're going to be in that area. Okay, so 1 minus 95 is going to give you 5%. Half of those are extremely motivated. Half of them don't care about statistics. So I would say 2.5. Half of 5 is 2.5. I'm going to go with 2.5 as the value. What? The percentage that are below 20. Oh, geez. Okay, I screwed up. I screwed up. Good thing you can do these questions over again. Here's 14. 14. 20 is over here, not over there. 20 is over here, not over there. It's obviously bigger. Okay. We could still salvage a little bit of this stuff here. All right. 20 is 2 standard deviations in the positive direction. Going from here to here is 95%. Okay, you have to include all these values over here, 95%. But then you also have to include this little sliver. So 95% plus the half, 2.5%, is 97.5%. Okay, now that's where they're getting their 97.5%. All right, let's see if we can. I can I could salvage myself here. Let's see what we got here. Okay, number 6. That's actually not a hard problem. Number 6. How about this one? Number 5. Okay, let's do this one. Let's do this one. Fresh sheet of paper. Actually, question 5 is almost like the one I screwed up. Okay. All right, use the 68, 95, 97.99.7. Widget weights have the mean of 61 ounces and a standard deviation of 5. Okay. Sketch a distribution. All right, we'll sketch a nice little distribution over here. Whoa, there it is. Average. Average is in the middle, which is what? 61. 61. And sigma is 5. 99.7 is 3 standard deviations, 3 sigmas here, 3 sigmas over here. Okay, so 3 times 5 is 15. So if I add 15 to 61, I get 76 here. And so if I subtract 15, I get 46 here. So between 46 and 76 is 99.7% of the data. Okay, so that is your 99.7. Let's say they lie between 46 and 76. Okay. What percentage lie between 51 and 76? Well, in order to answer that question, I need to know how many standard deviations away. How many standard deviations away are we from the average? Okay, 51 is smaller than 61. So here's 251. Let's make 51 here. And okay, let's be careful. Be careful. Okay. 51 is how many standard deviations? 2. 2 standard deviations. 2 sigmas is 51 away from the average. Okay, this is a tricky question. This is a tricky question. I caught it. Okay. And we look at the numbers. 76 is 3 standard deviations. So they're mixing you up. They're going to screw you up. 3 sigmas is 99.7 plus and minus. They want us to include this distance over here. How many lie within 51 and 76? Well, half of 99.7 is that distance here. Now over here, okay, 2 sigmas is 95%, but it's 95% plus and minus. All I want is half of that. 95% divided by 2 is this range over here. So take your calculator, 95. So within the bottom half, I get 47.5% here. 99.7. I don't want to screw this up. I don't want to screw it up. So I'm going to get my calculator going. Okay, 99.7 divided by 2 is 49.85. If you were to add these two numbers up, plus 49.85 plus 47.5, I get an answer that I hope is right, because if it's not right, I'll cry. It's nice. There it is. There is your answer. Okay. Again, here's what you're going to do. You got to worry about your sigmas, the number of standard deviations. For 6.2, the standard deviations that they do for every one of these classes are going to be evenly 1, 2, or 3, plus and minus. When they say 68, 95, 99.7, okay, 68% of the data, 1, 2, 3 standard deviations, 68% is plus or minus 1 standard deviation, 1 sigma. This is plus or minus 2 sigmas, plus or minus 3 sigmas. And they ask you the question, what percentage of the weights lie between 51 and 76? You've got to calculate the number of standard deviations away from the average. 51, 61, there's 2 standard deviations here. Between 61 and 76 is 3 standard deviations. So what you need to do is take half of the 99.7 to give you the upper half. Take half of the 95, which is the lower half, 2 sigmas, and add them together. That was a tricky question. That was a tricky question. What percentage of the widgets lie above 56? Above 56. This is getting messy. This is getting messy now. Let's see if we get a better picture. Okay, here's our graph. Here's our graph. Okay, 61 is in the center. 56 is over here. All right. There's 56. What we want to do is figure out what's the percentage of the widget weights lie above 56. All right. Okay. 50% is in this direction. Half the data goes from 61 to infinity. Okay. Don't even need sigmas. Anything bigger than 61, 50% of the widgets are going to be that. Now what you want to do is include this range over here. 56 is 1 standard deviation away from the average. Okay. And that's half of the 68, which is 34%. Okay. So 50 plus 34 is going to be 48, with 16% being below. 16% being below. And I'm going to go with 84. Yes, good. That's it. Talk to me. If you can do question 5, you got this homework done. You got that's the hardest, one of the harder questions there. Okay. You can do that one. But let's do 7. The researcher studying frogs is figuring out how much a frog can jump. The jump lengths appear to be normally distributed. Okay. Average of 95 inches and a standard deviation of 8. Okay. Take a sheet of paper. You're going to go through a lot of paper when you do math. Okay, let's grab a new sheet of paper here. I'll throw that out. Okay, jot down some data. Mean, 95%, 95 inches. Standard deviation, sigma, is 8. Okay. Use empirical rule. Okay. 68, 95, 99.7. 1, 2, and 3 sigmas. Okay. All right. So let's make a little picture. Here's the average in the middle, which would be 95. All right. Let's see where we are. What proportion of the frog jumps are less than 79 inches? Less than 79. Well, let's see. 79 would be over here. Let's make sure we're in the right spot. 79. Okay, now how many standard deviations away are we from 95? It looks like the distance from 95 to 79 is what, 16? 16 divided by 8 is 2 standard deviations. Good. 95%. 95%. We're using that rule there. What that means now is 95% of the data lies within that range. We want to find things that are, we want to find this area here. This is what the area we want to find. Okay. Now, here's what you want to do. We can calculate the really energetic frogs that are bigger than 95% is 50%. 50% of the frogs will jump greater than 95 inches. That part there. You want to add to it the guys that are between 79 and 50 and 95. Between 79 and 95, half of 95 is 47.5. That's over here in this range. Okay, so 50 plus 47 is 97.5 here. All right. And less than that. Okay, so what we calculated was the number of frogs that jumped greater than 97 or 79, greater than 79. 97.5% of the frogs went greater than 97.5. It must be that 1 minus that is going to give me 2% to a 2.5% would be there. So I'm going to say 2.5%, and that is 2.5%. Enter proportion as a decimal. 2.5% is 0.025. All right. What jump lengths represent the middle 95? Oh, that's easy. 97. I keep saying 97. 79. 79. All right. And 2 standard deviations away would be 16 plus 95. So 16 plus 95 is going to be what, 100 or 111. 111. Right there and 100 there. What's the probability of observing a frog that is longer than 103? Longer than 103. Okay. Bigger than 103, huh? 103 minus 95, okay, is going to be a 8. 8 is 1 standard deviation away. Okay, that equals 1 standard deviation. We're going to be working with the 68% rule here. 68%. All right, so let's see if we can do a little math here. Okay, 68% is within the range plus and minus. All right, so there's 61. 103 is over here. 34% is there from 61 to 103. Okay. In this range, it's 50%. Okay, so the frogs that go less than 103 are 50% and 34%. So 50 plus 34 is 84% that are less than 103. We want to find that are bigger than 103. So 1 minus 84%. The opposite, 1 minus, which is going to be 16%. And what do they want us to type in? Enter proportion as a decimal, 0.16. 0.16, right there. Okay, okay, you know what? You can try, you know what? Why don't we stop here? The next homework is going to require using Excel, and why don't we start fresh next week? Okay, we'll finish up 6.3 for sure, and we'll take it from there. So for sure, you can do 6.1, 6.2, and go ahead and try 6.3. But I'm not really worried about that. We'll worry about that next week. But after next week, you can take that test 3 after next week. You should have test 1 done, test 2 done. And this week you do 6.1, 6.2. But next week you'll do test 3. And then the hardest chapter is chapter 7. And so we're gonna do, I guess that'll be 2 weeks from now. And after we do chapter 7, it'll be easier. There's only one more chapter after that, chapter 8. Okay, what do you think? Questions, problems, issues? Okay, guys. Well, guess we'll catch you next week. All right, take care. Bye.